So this is probably, for most of you, the coldest... Wow! Wow! Fantastic!
You can try and guess how Bill Phillips made that explosion happen before you go to his public talk and let him show you himself. It involves liquid nitrogen, but nothing like the ultra-cool atoms that Bill Phillips works on now, or the laser cooling that he's most famous for. But before we go into laser cooling and ultra-cold atoms, let's think of how you produce everyday low temperatures, such as ice or liquid nitrogen. There are many kinds of refrigerators, and at one time even Einstein decided he just had to invent one too. But the basic idea always involves some kind of pumping cycle. You absorb heat at one location and emit heat at another location. A beautifully simple example of a refrigerator is this little toy. You have probably seen some version of this. As you can see here, it has two cylinders connected by a yellow tube and a piston in each cylinder. I don't think there's any special gas, just air at ambient temperature and pressure. The pistons are driven by a motor, and then the fun starts.
Start.
Here through a thermal imaging camera. Slowly, the left cylinder gets colder and the right cylinder gets warmer. How does that happen? How can this machine, which is completely symmetric, treat left and right differently? Well, the machine is indeed symmetric, but the motor is going in a particular direction, namely clockwise. That means the cylinder at 11 o'clock is a quarter cycle ahead of the cylinder at 2 o'clock. Let's animate what happens to the air inside the cylinders. The left cylinder is a quarter cycle ahead. Now let's imagine rotating the cylinders and bringing them closer till they touch. And now we see the gas gets compressed on the right and expands on the left. So it heats on the right and cools on the left. This is an example of a Stirling cycle, which is a variant of Carnot's cycle in thermodynamics. I don't know if the liquid nitrogen for the lab's vehicle comes from a Stirling refrigerator. There certainly are Stirling refrigerators which could do the job. The problem is that while you can make cyclic refrigerators very big, nobody's found a way of making them really small, like on molecular or atomic scales. So if you want to cool a small number of atoms or even a single atom, you have to think of something else.